Good morning, everybody. We'll get started in a couple minutes, but if you haven't yet, please download a copy of the materials for the tutorial. And if you're having any trouble launching a Jupyter Lab, let us know in the chat. So when you've got the tutorial and you started up Jupyter Lab, your screen, at least on the left side where you see a list of files, should look like what you see on screen now. And we'll go ahead and get started in about 2 minutes. I still see some people coming in. We do have a channel in Slack. Let me paste the link or the channel name into here. Particularly if you end up with a technical issue that we're having trouble solving during the session, we'll probably ask you to go over to Slack, and if we can't walk you through the issue in real time, then we'll set up an appointment to meet with you later this week and get it resolved for you. We are monitoring both the Slack channel and the chat in here, so either place is okay to ask a question. Julia, can you say a little bit more about which step you mean? Was that the creating a kernel step? Okay, so Julia, I would go ahead and try starting Jupyter Lab. And if Jupyter Lab starts up and we're able to run through the notebooks, you're good. If not, double check whether you've activated your environment. If you have your environment activated, then okay, then you'll see the name of the environment on your shell prompt. Yes, please do go ahead and start up either Jupyter Lab or Jupyter Notebook. We've tested all of the notebooks in Jupyter Lab. Almost all of them, maybe even all of them, will work in Jupyter Notebook also. Sheldon, if you normally use pip, it's fine to go ahead and do pip instead. Larry, excellent question. There we go. Larry's question was, how do you start Jupyter Lab? And I appreciate the question, Larry, because I am sure you're not the only person who had that question. But one of the things I like about SciPy, I don't know how many of you are at your first SciPy, but it tends to be a really friendly conference and questions are encouraged. And so if you've got a question, please do go ahead and ask. We do have a way to run this in the cloud. So if you just can't get things working on your computer, instead of spending the entire tutorial being frustrated that things aren't working on your computer, if you go to the tutorial materials, scroll down to the bottom, there's a link to Binder, which will start up a Jupyter Lab server for you in the cloud. You can work along with us on the notebooks there, and I'll put the Binder link into the chat. And then we're happy to make it, to meet with you afterwards and help you get your computer set up. Let me give you a tip about how to do that in our conferencing software. So if you click on the right, there's conversations and people in session. And if you click on people in session and hover over somebody, you'll see there's an option to schedule a meeting. And so feel free to do that. It's 9:05, so I think we'll go ahead and get started. Please do continue to help each other out in the chat with getting things running, or go ahead and use that Binder link to jump right in without having to install anything on your computer. My name is Matt Craig, and I've been coming to SciPy since 2014. As it happened, at that first SciPy I went to, one of the tutorials was the very first presentation about Jupyter widgets, although at the time they were called IPython widgets. I've been working on the tutorial for several years, and this year we have a really good mix of presenters. I'll have those presenters go around and say your name and maybe a word or two about what you do, and then we'll dive into the material. So, like I said, my name is Matt Craig. I teach physics and astronomy at a small university in Western Moorhead, or in Western Minnesota. The name of the town's Moorhead. And my secret goal is to have widgets take over the world. Eunice, do you want to go next? Or actually, we'll go in the order that's on the screen. So, Martin?
Yeah. So, hi, everybody. My name is Martin Renou. I'm a software engineer working at Quantstack, which is a small company in Paris. And we like to call ourselves a small team of open source developers, because what we do is develop open source software, mostly around Jupyter. So we work on Jupyter widgets, on kernels. We work on Voila, which we'll show at the end of this presentation, and many other cool stuff. So yeah, that's it for me. Itai, if you want to go next.
Sure, thank you, Martin. Hi, everyone. Welcome. My name is Itai. I am a software engineer working for Bloomberg. This is my I believe second SciPy as a presenter, and third as an attendee. Yeah, I hope you enjoy today's session. I think Mariana, you're next.
Hi everyone, my name is Mariana. I also work at Quantstack. I'm a software engineer there. I've created a few kernels and a few widgets for Jupyter. And yeah, this is my first SciPy. Excited to be here. And next person on my screen is Eunice.
Hi everyone. I was gonna say good morning, but people are all over the place. So hello. So yeah, my name is Eunice Benani. I work at Bloomberg currently as a software engineer. I'm working on a financial product that integrates Jupyter Lab to do data analysis. And it's my second SciPy, first one as a presenter. Back to you, Matt.
I think with that, Eunice, why don't you take it away, because you're presenting the first part of the tutorial.
Sounds good. Cool. Well, welcome everyone. I'm gonna navigate to the introduction notebook. So if you're gonna do that with me, which I recommend, you should open the notebook folder, and then it will be numbered 0. It's at the bottom over here. I have it open already. And so you were gonna go over a couple of things just to make the tutorial as smooth and easy as possible for everyone. So if you would like to ask a question, the best spot to do that is the chat section. It's going to be on the right-hand side. Many of you have already used it at this point. There is also the option to raise a hand or to ask a question in the Q&A section. Those are suboptimal for this process, so we're gonna pass on that unless you have a strong urge to post a question in the Q&A that you think maybe isn't relevant to for us to like discuss or have like a live interaction about. If it's something that maybe can wait, or it's something that maybe is like tangential to the topic at hand, you can post that in the Q&A, I guess, and we can revisit that at some point in the process. And then yeah, I hope, I didn't check, but I hope everyone can see my screen okay. Things are not too small. If that's the case, let me know, and one of the speakers will let me know, and I can increase the font. But yeah, in terms of the Jupyter Lab essentials, this is just a few pointers. If you've never used Jupyter Lab, to open a notebook, you double click on it. To hide the file browser, you can click on the folder over here. If you want to make more room in your workstation, you can, I think, also do a Command B to toggle that. To run a single code cell in the notebook, you can use the play button at the top, or you can push Shift and Enter, and that will run the cell.
Eunice, sorry
Yes.
to interrupt you. Someone is asking to zoom in a bit.
Okay, great. Thank you.
Apparently it's too small.
Okay, let me know if that's still not good enough, whoever said that. I'll keep going in the meantime, but yeah, please ping me again if that's still an issue. And then, yeah, to add a new view for an output, you can right-click on the output and select Create New View for Output. You can use Tab to autocomplete and Shift-Tab to show documentation. And one thing that we're going to be using for the solutions is the comment and uncomment comment feature. So if you want to, you could just add a hashtag or at the beginning of the line, but you can also just like toggle that with command slash. Great, so we're going to get started with the actual content of the tutorial now. So yeah, interactive Jupyter widgets. They're an object that represents a control on the front end, like a slider. A single control can be displayed multiple times, but they all represent the same Python object, and we'll get into what that means a little later in the tutorial. But so I've run the first cell. If you want to do that alongside me, you can see how that behaves. You see that this slider creates a float slider that has a starting value of 7.5, has a min value of 5, a max value of 10, increments in step of 0.1, and you can add a description that is displayed at the beginning of the line here that tells you like what this is. So the minimum is 5, maximum is 10. Okay, just overwrite that. Great, and then you can trigger actions in the kernel when a control value changes by observing the value. What that means is that you can basically, in this line, what we're doing is that we're observing the change in the value. And so if I run this, and then I display the square value, the square of my input here, that is 10, is 100. If I change that to be, say, 5, and I run that again, now my square value is 25. And the way I've done that is that I've defined what square is as a global variable. Here I am defining this function that handles the change. I'm declaring that my variable square is a global variable, so whenever, so it's basically has a global scope. And then whenever the value changes, I'm actually recalculating square and reassigning that value to the variable square, which is why I can see that take effect whenever I change my input over here. So this is kind of a way that it's a way to define a widget that's a little clunky. Well, not clunky, but it's very explicit. One way to do it that is a little faster is to use interact. And so I'm just going to run these 4 cells over here. And the nice thing about this is that we've basically reduced like the number of lines drastically. And what we've done here is that now that if I change the value of x, I can see this changing directly because interact is magical. So yeah, so we're going to get into interact more later on. So if you have questions, wait until that happens to figure out if you need to ask them. This is just a little flavor of what's coming ahead. And then to load exercise solutions, you will have to uncomment this and then run it. This basically just loads, as like the syntax is indicating, it loads the solution from whatever path is indicated here, and so it did its magic. It's now here, and so you have to run that again. So now if I run that again, I get to run the actual code and see the solution. Yeah, I hope that's clear. If that's not, you can play with it. Ask us any questions if that doesn't make sense. Here's some additional reading for you if you are interested in knowing more about how the Python widgets are built. They're basically in 2 parts. There's a Python part and the JavaScript part. I'll let you browse this, and feel free to ask us any questions if you'd like to do that. So that's it for the introduction. I'm going to pause for 30 seconds and look at the chat to make sure that everything is going okay, and grab a sip of water. But yeah.
When you come back, Eunice, there's a question in the Q&A.
Okay, great. I think all the widgets should work in Jupyter Notebook. So yeah, Jupyter Lab is a dependency. I don't think is gonna that shouldn't be a dependency. Any widget has like a kernel component and a JavaScript component, and that's agnostic of like what notebook server you're using. So that should be fine. I like the emojis. That's cool. Cool. All right. So let me see. So we're 15 minutes in. Great. So now I'm going to go over a little bit of an overview of what you can do with Itai widgets. So this is the notebook right below introduction, I believe. So if you go to your file browser, it should be right there. It's numbered 1. And this is not, we're not going to be running anything. So you can actually just listen to me ramble about this for a little bit. But this is basically giving you a little bit of perspective in terms of what you can do if you become very proficient with widgets, and the extent of the universe that you can, no pun intended, there's some like astronomy stuff at the bottom. But yeah, there's a lot that you can do with widgets. So this is the little paragraph here cites a couple of different packages that can be used in order to create widgets. So BQplot, for instance, is one that was developed initially by Bloomberg. It's now open source. It provides a plotting tool in which the lines, the markers, the labels, the legend all act as widgets. So they're basically all widgets, and you can do all things widgets related with them, which when you become proficient with widgets, you will know what that means. The widely used plotting library Matplotlib, which I'm sure a lot of you have used, also has a widget interface, which is not as maybe not as popular and not as well known, but it is nevertheless there. Another example is Itai Volume, which does 3-dimensional rendering of point or volumetric data in the browser. And Itai Widgets also has a new addition called Output, which can display any content. It can be rendered and can be rendered in a Jupyter Notebook. So, so this is an example of a dashboard that you can create with widgets. It's one that I think, Matt, you put together, right? And so if you want to look at the dashboard.
It was a colleague of mine.
It was a colleague. Okay. So if you want to look at the dashboard, it's over here. The code is over here. And then this tells you like what technology or what dependencies, what packages were used in order to create all of the widgets that are in here. And same thing with the binary star simulation. Yeah, so Py3.js, BQplot, Itai widgets, and you can run it through MyBinder. And there's the source for this example is at the bottom here if you're curious. Great, so that's it. I'm going to pause again to see if there are any questions. Great. Okay, so moving on, we are now going to the Interact folder. So at the top here, it's number 2, and I'm going to be opening the first notebook at the top, which is this little guy over here. I'll give you a minute to open it. Great. So this is going to focus on Interact. which we got a little sense of at the beginning of the introduction. Sorry about that. And we are going to look at how Interact works and how the basics of it, how you can create a widget basically, but what we did in the introduction, but in more details. So this is just the imports. So at the most basic level, Interact auto-generates UI controls for function arguments and then calls the function with those arguments when you manipulate the controls interactively. What this means is that basically you can create a function and then you pass that function to Interact. And what Interact will do is that it will take the function, it'll take whatever argument you're passing it, and it will apply the function to the argument that you're passing it. And so now that we've done that, we can move this around. And again, as we saw in the introduction, this is just doing what the function has defined, which is just multiplying your number by 3 and displaying that at the bottom. If you pass true or false, Interact will generate a checkbox. And so checkbox, a true is cast to 1, which 1 times 3 is 3. If it's 0, then it's 0. If you pass a string, Interact will generate a text field. So for instance, now I have a text field. I can write whatever I want in here, and it just takes the string and it multiplies it by 3, which concatenates it and creates this beautiful string over here. Interact can also be used as a decorator. Now I'm going to get into what a decorator is. We did that. The team did that last year. But if you're curious about it, we can talk about it more offline. We're just not going to get into it during the tutorial itself, unless there is. Let's just say we're not going to get into it. So this allows you to define a function and interact with it in a single shot. So the nice thing about, again, the decorator is that this is 3 lines, and it does exactly what this was doing over here, defining the function and then calling interact on it. So it's a little bit of a syntactic sugar to just make things a little more readable, maybe. Fixing arguments using fixed. This is something that you will do if you want to fix an argument and experiment with the other one. So say there's a function that takes 2 arguments that then returns a tuple containing the 2 variables. And so I'm defining h over here. And then what I can do is that I can call the function with both of them. And so at this point, I can modify p and q, and the tuple at the bottom reflects the values that I'm assigning to p and q. But if I wanted to fix q, I could do, oops, that is not, I'll just type it. Now q has a fixed value of 20, which you see in the second part of the tuple, and then I can still modify p over here. So that's fixed. It's done. Widget abbreviations. When you pass an integer valued keyword argument of 10 to interact, it generates an integer value slider control with a range of -10 plus 3 times 10. So what you've noticed, you might have noticed this before, I passed 5 over here, and what it did is that it starts at -5, which is minus the value that I'm passing, and it ends at 15, which is 3 times 5, which is the maximum value that it assigns to it by default. What you can do is that you can control those values, and so you can add a minimum value, a maximum value, the step that you want to take, and the value that you want the slider to start with. So this allows you to have more control over the slider. And so the way you would do this is that you would define this widget object that you're passing into the interact function. And this allows, and this is an option that you have in interact. You can pass either a value, in which case it would take that value and it would turn that value into an int slider, and then apply it to the display object that you're getting, or you can just pass it directly the widget that you're defining here, and have that flexibility. Okay, I'm afraid that I might be going a little fast. I'm going to check the chat to make sure that everybody is following. Great. Okay, well, I don't know if it's great. If anyone feels like it's going too fast, let me know, rather than there's always a tricky part about asking, is everyone okay? And no one speaks up. Great. Okay, so yeah, so that's about widget abbreviations.
Eunice, can we just had some comments coming in asking you to slow down a little bit.
Okay, great. Great. Okay, perfect. I'll slow down a little bit. Thank you for letting me know. Much appreciate it. Great. So it is fun to like play around with these. So just feel free to like change things around to see how the widgets behave and what that means. And so like one thing that we can do here that I think maybe will help understanding this is that we can see how, like, at this point I'm just passing in a value and it's inferring that I want to create a widget, and it's giving the widget the defaults that I mentioned earlier. And so now it's going to start at -10 and at 30. But again, I can just replace this with like the widget in slider, define the widget, and then pass it to the function. And I guess it's the beauty of Python that you can just like use like two signatures for like whatever this is getting. So anyway, and so this works, and you get like actually you get the same thing, which maybe isn't like super helpful. But if I change this, then now the maximum is actually 20, right? Great. So yeah, so this is getting into like this is a little table to remind you of the different keyword arguments that you can give to interact in order to get like the checkbox or the text box or the slider. Yeah, so note that a dropdown is used if a list. We haven't gone over that yet, but if you pass interact a list of tuples or a list, it will have a different behavior. So I'll go over the part of the table that we haven't seen yet. So if I pass interact a list like orange and apple, I'm going to go over that example in a little bit, but just as a heads up, then it will create a dropdown as the widget. And then if I pass it a list of tuples, it will actually get the second value of the tuple, but display in the dropdown the first value of the tuple. So we'll get into that in a second. But yeah, so now you've seen how the checkbox and widget works. The text widgets work above. There are more details about different abbreviations for sliders and dropdowns are given. If a tuple, so for instance, in this case, this is specifying that I only care about the range of the slider that I want to display, and so this is telling the slider that I want the minimum value to be 0, and the maximum value to be 4. And you can do the same thing here by specifying the step argument, which is going to be the third number of the tuple. And so now I have a slider that goes from 0 to 10, but with a step of 0.1. Yes, so we are gonna take a break for a little exercise here. So this is a reverse function that just takes a text and reverses it. And we're trying to use interact to make interactive controls for this function. So step one is to figure out what control you want to use, what control makes sense for this, and then the second part is to actually implement that control. Yeah, so we'll take a little break here and let you think about this, and we'll get back in a little bit. Let's take let's take maybe 5 minutes for this. So at 9:30, or 9:35 my time, it's like 35 after the hour for wherever you are.
So maybe we can take the opportunity to answer some of the questions I saw. So in the Q&A section, can a slider be a date? So the answer is yes. You can have a selection slider, for example, and in your selection you can have a date string if you want, for example. And do these sessions get recorded? I think so. I'm not entirely sure, but I think so. Yeah.
Yeah, I'm pretty sure. Yeah.
Yeah, on my screen, I see the record button. There's a record indicator. So
Cool.
typically, SciPy is really fast about processing these. So by the beginning of next week at the latest,
So how do you use similar widgets while using PyCharm IDE? I remember PyCharm actually supports SciPy widgets, so you can use SciPy widgets and other widgets we will show today in PyCharm. And it will be the same for VS Code, if I recall correctly.
We also got a question about decorators. If there's any recommendation for documentation, I would just, I don't know that there is, but I would just do a Google search for it. I think it's pretty well documented online, but maybe Matt, I don't know if you have any specific resource.
yeah, I'm tracking something down. Give me a minute. I'll put it in the chat once I find it.
Cool, thank you.
Can you address, Julia had a question in the chat. Can you address that? It was about what we're supposed to do.
Yes, so are we supposed to do just reverse? Yes, so you're supposed to create a widget that uses reverse and that does something with it, right? That you can leverage a type of widget that we've seen earlier to do something a little more clever than just reversing a string. Sorry, it's intentionally vague because this is basically like letting you play with widgets and figuring out like what can you do with a function. to just for you to play with widgets for a little bit. So anyway, but it's at 9:35 now. So I'm actually gonna go over like one solution. So this is something that you can do. So you can just like have a little widget that contains text, and you know, like you can just like type a sentence here, and now it's the sentence that you're typing is the one that's being reversed, as opposed to just having a like a static reversing thing. So yeah, so I'm going to be moving on, but let me know if that doesn't make sense. It's basically just, again, it was for you to experiment with widgets that we've seen before. Hopefully that makes sense. So yeah, I'm going to be moving on. Great. So for both integers and for float value sliders, you can pick the initial value of the widget by passing a default keyword argument to the underlying Python function. So this is what we were talking about earlier. So this is using the decorator, and it is passing a default value of 5.5 here. So so now you set that value to be 5.5 to start with, as opposed to whatever interact was getting earlier from the second part of from the second argument that you're passing to it. And then this is getting into what I was talking earlier about the drop downs and the values that are assigned to them. So if you pass a list, you get a drop down that contains the items in the list. If you pass tuples, you get a drop down, but what is being passed to the function that you're calling is actually the second part of the tuple. So if you pass 1, then you're actually going to be passing 10 to the function, and you're multiplying that by 30, which gives you, by 3, which gives you 30. And then if you do the same thing with 2, then you get 60. And in the example of a basic interactive plot, so these examples are obviously not very complete or very useful on their own, but this is like, they're stepping stones for what you can do with widgets, and this is something that is more interesting. So if you run these cells, what you can do here is that you can plot something that has like two arguments. It has the point at which the curve will meet the ordinate axis, and it has a slope of the curve, and so you can interact with that in order to modify your plot in real time, which is, I guess, a little cooler than what we've seen so far. Great, and so the last exercise here, and maybe, I don't know if this, the other exercise took a little longer, I think, than maybe people needed for it. So maybe we're gonna do 2 minutes for this one and see how that goes. So this is for you to experiment with the plot functionality, and you're basically going to be getting the same thing as above, except that it's a sinusoid that you can, again, like, it has 2 parameters that you can control. So yeah, I'm gonna set a timer for 2 minutes. Actually, kind of perfect because it's 38 after the hour, so we'll stop at 40 after the hour, and yeah, so go ahead and get started on that. Oh, that's a great question. So we got a question in the chat about whether we can export an interactive plot as a standalone object. So we're gonna be getting into that a little later with Voila. I think Martin might have temporarily left for a little bit, but that is one way to do that. There might be other ways to do that as well.
Yeah, and for IPyMPL, you can, as you can see, there is a small diskette. I don't know how to say that in English, I'm sorry, but you can save as a PNG if you want. It's the latest icon in the column, the latest button.
This over here?
Yeah, this one. And this one will actually download the plot as an image.
So that won't be interactive, but it is the plot as it appears, as it is right now.
Exactly.
Right, but if you wanted to keep interactive, I think the simplest way to do that is probably Voila. maybe?
Yeah.
Great.
And I guess we'll come to that later, yeah.
Yeah, exactly. So yeah, stay tuned for that.
Actually, it's not the only way. Well, to have it interactive, voila would be the only way, I guess. Yeah.
Great. Oh, I was wondering what that tune. Oh no, never mind. It's a different thing. I set a timer for 2 minutes just so I wouldn't forget myself, but it hasn't gone off yet. Great. That's it. So yeah, if you can load the solution as I said earlier by just uncommenting this, running it, and then running it again. And this is not going to show for me because I already loaded it, and so the object is probably at this point it's lost to the ether. I don't think there's any good way to find it, but I would have to restart my kernel to get it. But it should show up for you. And yeah, again, let us know if you have any questions. I can go back to this questions if this is the exercise if that's the case. Great, and so next we have an optional exercise. So this is just more about Interact if you're curious to look at this on your own. And again, happy to go over any of this later on. But for the sake of time, we are going to look at widget basics. Let me check that we don't have any break. Great. It's kind of a long stretch for that any breaks. I'm realizing this now. Great. And so we're going to open this notebook now. So this is a little bit of a repeat, but what are widgets? So again, as I said earlier, it's an object that has a representation in the browser and controls on the back end. Yeah, so I'm gonna go over this quickly. This is basically just showing an inslider as before, but it's getting into like what is the how does this get displayed, right? The reason why you're seeing the slider here is because this is returning the Python like wrapper object inside of the slider, and that shows up as a JavaScript object that you can interact with. Another way to display a widget is to call display on it, right? So if I do this will make it a little bit more sense maybe. So if I do like print hi, right? I just see print hi. I don't see anything else. But if I wanted to display the widget that I've created here, I could do display and then the widget, and that also shows me the widget. Right. So I hope that makes sense. We're going to get into like what is contained inside of the widget object, and I think it'll start to make more sense then as well. And if you call another display on here, then it redisplays the widget. The two are the same widget, and this is getting into like also why this happens. So basically, what happens, and that's what this diagram shows. There's a widget in the back end in the kernel, and then what happens on the side of the front end is that you're reaching out, you're accessing that same object, right? And then you're just displaying it however many times you want. And so the widget model is this thing that's created based on the widget that you can just like display and create a view for. And you can create 2 views, 3 views, it doesn't really matter because they're really the same object deep down. Maybe it's getting a little metaphysical, but yes, that's how you're able to like display the same widget many times. I'm going to pause here and see if anyone has questions about this. Okay, great. So we're gonna keep moving on. So this is displaying a widget and then looking at the value of it, right? So if you set the value to 56, if you run this cell over here, it is querying, it's basically just fetching the value that is associated with your widget. To set a widget value, you can do the same thing, and this is reflected over here. So if you notice, I can like try and set it to like 1,000, for instance, and that won't work because my int slider is defined with a maximum of 100. And that's something we're going to have a little exercise on a little later. But basically it should otherwise be reflected in the widget because you're setting that widget model value to be 10. And so this is what I mentioned a little while ago. These are all the keys that are associated with the widget. And so we can see there's the value here, but there are other things like the min and the max that we saw earlier that you can set, and then the step, which also we saw earlier that you can set. So yeah, so these are all the keys of your widget object. Yeah, so this is another way to create like, for instance, in this case, you create a disabled text box. So if you do that, then it's a text box that you can edit. Otherwise, it's not. And then this is linking two similar objects. So this is something that's handy when you are dealing with like multiple widget types. So what I'm doing here is that I'm creating a slider. I am then creating a floating text box, and then I am linking the two of them. So I'm linking the slider and the text box to be linked. And what happens when I change the slider, I actually see the value reflected here, and vice versa. When I change the value of the text box, I see it reflected, to the extent that, again, this is what I was mentioning earlier. As long as my value in the text box is lower than 10, it'll be reflected in the floating, in the float slider. Otherwise, it'll just be set to the maximum. And again, we're going to have a little exercise on that a little later. Great. And then this is actually, yeah, I don't remember if I've made these changes upstream, so let me know if this isn't clear. But basically, in this line, what I'm doing is I'm creating this link, right? And I can actually return that link and assign this variable to it, and then I can unlink it, right? So if I run this, I'm now changing the float slider, but nothing is happening here because I have that much control over how the two widgets are linked together. Great. So going to take another short break and look at the chat to make sure that no one has questions. Can int slider take arguments? Yeah, so int slider, I'm not sure what you mean by that, but this is a float slider and it's the same thing. So if I make this an int slider, and I set the values to be ints because that would be nice. Just going to delete this. And then I can display my widget. So this took arguments, right? It took a value, a min, a max, and a description, right? And this is creating an int slider. So yeah, let me see if that hopefully answered the question. Why does an interactive plot disappear after multiple cell execution? Yeah, so that is a that happens because basically you're displaying a plot, but you're not it's kind of, it connects to what I was saying earlier about the repr. attribute of an object. So the repr attribute of an object is actually what is being displayed when you display that plot. But I believe that you can save that to a variable and then display that again. It might be worth spending time on this if a lot of you are having issues with like displaying a plot many times, and I'm happy to do that. I think that the bottom line there is that there's a better way to display plots than I think what is being written here, what maybe most people do. I haven't done that in a while, but I'm happy to get into that if that is useful. To the speakers, you have a better understanding of what questions people have been having so far. So should we spend 5 minutes on this?
I dropped a brief explanation into the chat. I think we can probably go on.
Okay, great.
And essentially, it's because in the plot code, you're plotting to a specific matplotlib figure, which is named 5. And so once you've deleted that from the view, you can't see it anymore, but you keep, that's the plot that you're updating. So if you take the figure number out, you can display multiple times.
Okay, yeah, that makes sense to do that. Cool. Great. Okay, so looks like, how are we doing on time? We have 20 minutes. Yeah. I'm gonna try and go a little faster. But
if we could make it through the widget list and its exercise in that time, then we can probably take a break and come back and wrap up the output after that.
Output widget. Okay, sounds good. Great. So let's go back up one folder and then go into widget list. I'm gonna close this guy. And let's open widget list. Give you a second to do that. Yeah, so let's just edit. All right, so I assume that you've opened this with me. This is actually, it's very important that you do open this with me because this is more of a documentation kind of platform for you to browse, and you'll have a much better sense of like what is available to you after going through this. So so I'm just going to run these cells. Running this cell actually loads resources that are saved in the folder above in the reference guides. And so this gives you a pretty comprehensive list. I'm not sure how exhaustive it is, but of all sorts of widgets that are available to you. So this ties into like the question that we were getting earlier about like what other types of widgets are available. You get a well, I will just let you go through this. I'll give you a little bit of time to do that. One way that we're gonna be exploring this is we're gonna have a little exercise here at the bottom that will help you maybe like figure out how to navigate those resources. Yeah. So this is code that was taken from a previous notebook that I mentioned earlier. This is the part where I am changing the value of the text box or the float text box here, but I'm not seeing that reflected in the slider at the top because I have a maximum of 10, right? And so if I assign a value above that, nothing happens, or I'm capped at 10. So the slider having the wrong value is something you can fix. You're going to do that by replacing float text with something else. And I will give you, let's do a little more than 5 minutes. And so let's, yeah, this is actually worth it though. Yeah, because there's a lot to explore here. So let's do a little more than 5 minutes, and we can get back right on the dot at the top of the hour, and we can keep going after that. And I am actually going to let you also look at the next two exercises, which are also meant to do the same thing. Which they're both meant to like help you figure out what resources are available to you and what widgets you can use. right? So let's meet back at the top of the hour, and we'll at that point we'll have done everything to the bottom of this page.
So the file upload, it will go, so depending on your setup, if you're running Jupyter Notebook locally, the file upload will just move your file to the location where you started the Jupyter command. But the file upload can be very useful if you have a setup where Jupyter has been installed on a server. So for example, if you use MyBinder, you can upload a file on the server using the file upload widget, and then use it in Python and do whatever you want with it. And actually, maybe I'm wrong on this. The file upload, it will contain a data attribute. which contains your actual file.
Great. So it's about time. I hope you were able to look at all the widgets that you can play with. Controller widget's pretty cool. I haven't used it myself, but it does seem like a cool thing to try. Cool. So I am gonna open the other notebook in this folder, and we're gonna be talking about output widgets. So an output widget can capture a display, standout, some standard error, rich output generated by IPython, and we're gonna see examples of what that means. So, for instance, in this case, what I am displaying as an output is this cyan 1 pixel solid border that you can see here. The cool thing is that you can, once the widget is created, you can directly output things into it using Context Manager. So if I print hello world without as an output, I get all these hello worlds displayed in my output widget over here, and you can do the same thing with a YouTube video. So this is doing the same thing. It's using out as an output and then displaying a YouTube video, which is a Jupyter interactive widget from a year previous to this one. You can display complex MIME types, such as nested widgets in output widget. So you can. I'm hearing a hot mic. Am I hearing something?
Oh, sorry. Yeah, I was going to suggest, is this maybe a good time to show people how to create another view for an?
I think it comes after, or
okay, sorry.
Yeah, I think it might be at the bottom of this. But if not, remind me at the end of this, and we can go over that. Great. So yeah, you can also like add like an insider, for instance, to this output widget. You can also append outputs to the output widget directly with the convenience methods, append standout, centered out, centered error, and append display data. So yeah, if you've downloaded the tutorial a little earlier than yesterday, there was a little this mentions an issue that is actually not an issue anymore. I was able to add a widget to the output widget using append display data. So that should be fine at this point. So this is creating at this point. This is creating a new output widget. It consists of the same like solid cyan border, and then I'm appending centered out, and I'm printing this basically, and then I am adding a YouTube video, and you can actually do the same thing with like a widget in slider. So if I do append display data, and then at my widget slider, that should have worked. Data. Great. So yeah, so you have the ability to do that with and also just using these convenience methods over here. And if you wanted to, maybe I'm wrong, maybe you're not. We don't see it later, but I thought we did. So if I wanted to so what Matt was saying is that I believe what Matt you're getting to is how you can create like or display a widget a second time. I think we saw that earlier, but
what I meant was if you right click on the widget cell or on that output cell and create new view for output.
Okay.
The reason I brought it up is that you were scrolling back and forth between some of the steps and then going back up to see what the widget was doing, and this lets you see what the widget's doing while you keep going through the notebook.
That is handy.
And it's a handy trick if people aren't familiar with that in
Mm-hmm. Cool. Yeah, thank you for that. Yeah, if y'all didn't see that, so it's a right click and then create new view for output. I think it is in the tips at the beginning if you want to see that again later, but oh, it's interesting. Why does it not do that? Oh, I guess I have to run it again now. That's odd. Cool. Okay. Great. And then if you clear the output, this is displaying out, so that's not going to work. But that should clear your output over here, so that goes away. Inside enough, the in slider is not going away. So, that's odd. I think the in slider should be disappearing. So maybe that's a bug. Maybe it's not, and then I'm not. But yeah, so like running this, you get the in slider, the oh, wait a minute.
But
so this
it looks like it's not in the output.
It is not in the output. Oh, that's so interesting. Okay, that's definitely a bug. So maybe the issue still hasn't been resolved. Maybe that was the status of the issue the last time as well. But it's interesting that it'd still display it. It just wouldn't be part of the output widget. Anyway, so that's fun. So let's ignore that. There's a link to this issue if you're interested in tracking it, or it seemed like it's been closed, so I don't know if it's been resolved or what. But yeah. Anyway, so clearing the output causes everything to disappear. It actually also doesn't actually clear the. Oh, I guess sorry. This is actually part of the output widget, so that makes sense. So if you're wondering like why is the cyan line border still there as I was, it's because it's the border of the output widget, so it's not actually inside of the widget. So it makes sense that the output would be clear, but the border would still be there. Great, so that makes sense. And then you can also do the same thing with a decorator. You can decorate the function that you are, where you are like printing things from. If I do that, then I get this like giant trace inside of my output widget, which is kind of scary, but it is meant to be there because that's what I want, right? I am going to do what Matt said because it is good. And so this is my my output view, and now that I've run this, I can I see that the output that I'm expected to see in the output widget is actually present here. This goes into the output widget line, and then there's the exception trace that I'm raising here. So that's handy if you're if you want to like put all your output inside of an output widget. And then it supports the clear output keyword argument. So if I pass it, is it capture? If I pass this true, then it will clear the output widget every time the function is invoked. So this is actually, nothing is happening here because I'm running the same function and it's displaying the same thing. The thing that is interesting that I tried yesterday is that if you use it in combination with wait equals true, and then you just like pass here and comment this out, this isn't going to be replacing. It's not going to be clearing your output. But if you say wait equals false, in this case, what this is saying is basically I want to clear the output only when there is a new output being printed if it's true, right? So if it's false, sorry, I'm not explaining this very well, but this is waiting until there's new output to be displayed. So until there's new output to be displayed, you will just keep whatever was there before. So I guess a good way to prove that to you is to see that now there is an output here. If I say false here, and then I comment this out, this is going to clear the output widget, right? Because I don't care that there's no new output that I'm passing into the output widget. I'm solely concerned in like clearing the output every time I run the function. Anyway, so I hope that made sense. You can play with it. The keyword arguments are here at the bottom. It makes a lot of it's handy to know that you can do that. Yeah, so I am going to do one last thing to just like show that you can still, despite the fact that it's being called with a decorator and has a bunch of keywords argument, you can still clear the output this way as well. Okay, so I'm going to close this now. So output widgets as a foundation of Interact. This is showing that you can create a bunch of sliders and then have the output be on the side, and you can stylize that however you want. I'm gonna go over the next couple of sections pretty quickly because I think we're running pretty low on time. And then the sidecar is like output but on the side. So this is kind of a cool feature where like it makes a widget appear on the side of your notebook, and then you can use it to like type things, and you can also call it from functions. So this is using a decorator to capture things that are being passed as the output widget inside of the function. And when you call the function, you will, every time you call it, you will see the output of that be printed in the sidecar. And you can also put widgets into the sidecar as well, which are getting a little squished, but you can resize it. And then you can also clear the output, just like the output widget that we saw earlier. It's just on the side. Great. So as an exercise and a break, we're gonna combine the two, and we are giving you a longer break this time because it's been a little over an hour. And so we're gonna take a 15-minute break, unless anyone feels strongly about this. And we are gonna let you look at the exercise, take a bio break, grab a snack, stretch your legs, and we'll be back in let's say it's 27 minutes after the hour. It's been we've been lucky in the rounding of the rest of the tutorial, but I guess we're gonna stick with 27 after the hour. Okay, thank you. We'll see you in a bit. Oh, thanks for all the emojis, guys.
So Hillary, any reason why the sidecar wouldn't appear? Instead, it displays inline. So Did you just install Jupyter Lab Sidecar? If you did, maybe you need to refresh the Jupyter Lab page and re-execute the code. This would load the lab extension.
All right, I think we are 28 after the hour, so it's time to resume. Thanks again, Eunice, for your presentation. And next up, we have Martin, who's going to talk about widget events.
Yeah, so I will share my screen. Please yell if you don't see it, but you should see it now. So the next part is widget events. It will be part 5 events, and I will show this notebook, widget events that IPNB. So as Eunice showed you, you have two ways of creating widgets. You can either use Interact to automatically create widgets and bind events to have some cool interactions, or you can create widgets manually. And when you create widgets manually, you need to hook up to events manually as well. So in order to support events, widgets actually they inherit from traitlets, which is another Python library. And this library allows for properties validation and observation. So I would show you a trait class as an example. So I created an identity class, and it has a username and an age property. So the username is a Unicode value and the age is an integer value. And they are both validated by type. So if I create an identity instance, for example, John, and if I pass username equals 3, it should fail. This will tell me that the username trait of an identity instance is expected to be of a Unicode string. So yeah, it's validated by type, but it's also validated by value. So for example, I've got the age property and I've got a custom validator that will validate the age value. So if it's negative, it's not a valid age. And if it's too high, then it's not possible and it should fail as well. So if I create Jane Doe, age 25, and print the age, it works.
Martin, sorry.
Sorry, can you make the type size a little bit bigger?
Yeah. Let me just... Is it better?
I think that's good now, yeah.
Okay. So, so properties, they are dynamic, so I can change it dynamically from Python, doing age equal to 32. And then if I print it again, it will be 32. But it's validated dynamically. So if I do 200, then it should fail. And this will trigger my custom validator, and this will say this is too old to be true. So that's traitlets. So you have validations of properties, but you also have observation. So this is using the observe pattern that is well known, and all the trait classes, they have an observe method which allows you to hook to some changes in the properties and to call Python functions when they change. So observe, it takes a handler, which is the Python callback that you want to call, and it takes the name of the properties you want to listen to. So if I want to observe Jane's age, and I want to print the age whenever it changes, and show it in an output widget, and if I change it, it should print it. So let's see. So this prints the change event. So as you can see, every time I change it, it will call my callback. So the change event, it contains the name of the property that changed, the old value, the new value, the widget itself. I mean, it's not a widget, this one, it's just a trait class, but all widgets are trait classes, and the type of the event. So as I said, all widgets are trait classes, so they all have the observe method available. So if I create a label widget and a slider widget, I can, for example, observe the slider value and then call handle slider change whenever it changes. And in there, what I do is I will update the label widget, printing the slider value is either negative or positive depending on the slider. So if I execute this, if I move the slider, as you can see, it updates the label widget dynamically. So this is how you create interactions between widgets. So like I said, the callback signature, the object that it takes is a dictionary containing the new value, the old value, and everything. So you can actually look at those values and, for example, print them. So if I move the slider, it will show me the old value and the new value every time there is a change. So why would you use observe instead of link? So you saw before, Eunice showed you how to link widgets together. You can link a slider to a text widget, for example. But sometimes using observe is actually more powerful. And it's more powerful if you want to change the value. If you have a first slider and you want to change the value of the first slider to set the value of the second one, then linking is not what you want to do. You want to observe, change the value, and then set the value of the new slider. So here I've got two text widgets. The first one represents a temperature in Celsius degrees, and the second one in Fahrenheit degrees. So here what I did, I observe the Celsius degree value. And whenever it changes, I will call onCChange, which updates the Fahrenheit value, calling my C2F function, which is defined here, given the new value of the text widget. So this means that if I change this value here, and press enter, it dynamically updates the Fahrenheit value, making the new computation of the new value. But as an exercise, I will let you to actually do the opposite, which is to listen to Fahrenheit value changes to update the Celsius value. Because as you can see, it doesn't work. It doesn't update the Celsius value. So you have to do it yourself to observe, call the right function, and it should work. So I can give you a couple of minutes to do that. Okay, so first, what we need to do is to we'll maybe fill this callback. So when F changes, then degree C value will be C to F, F to C of the new value. Then what I want to do is observe the degree F value. And I want to call on fChange when it changes. So if I execute this, it should work. Okay. So then advanced widget linking. So as you could see, you can link two widgets together using the link function. Here I link the slider 1 value to slider 2 value. This means that whenever I move slider 1, it will move slider 2. If I move slider 2, it will move slider 1. But you also have the directional link. So using the dlink function, you can link a source to a target. And if I move the source, it will update the target. But if I move the target, it doesn't update the source. So this is directional. And then I can call unlink if I want to break the link between the sliders. Then, okay, so one thing that is nice is that you can actually do the link in the JavaScript world using
there's a request from the chat to slow down a little bit.
Okay, sorry. So you have the JS link. You have the JS link function. So this one allows you to link the same way as using the link function. But the link is actually done in the JavaScript world. So in your web page, not in Python in the Python kernel. Because as you know, the Jupyter Notebook, it's a web application. So it has a server side running your Python code, and it has a front-end side in your browser. So the JS link is actually done in your browser directly. And this is useful in some cases, and I will show it to you later during this presentation. But basically, they behave the same. You won't see much differences, but there are some details. And same, you have a directional link for the JavaScript one. So you can link a source to a target, but not the target to the source. So some widgets offer this continuous update property. And this property is useful when, for example, you say you have a slider and you want it to drive some inputs for a computation you want to make. If the computation takes time, so you don't want to trigger a new computation every time you move the slider. So let me show it to you. For example, I can link the first slider to the second one. And if it's continuously updated, then it will continuously update. Now, if I do continuous update to false, it won't do that. So for example, the first one, which I said continuous update to false, if I move it, it won't move other widgets. And it won't trigger observations, and it won't trigger your callbacks. So if you have a computation that takes time, you don't want to trigger the new computation every time you move the slider. You want to be triggered only when you ungrab the slider. So this can be useful to speed up your interactions. Now, some widgets like the button, they provide special events that you can hook up to. So for example, the button, it's not a stateful widget. It doesn't have a clicked state, for example. But instead, it provides an onClick function, which allows you to bind a callback function that will be called when the button has been clicked. So if you create a button widget, and if you do button onClick, unbutton clicked, then this will call your onButtonClicked function, which is defined here, whenever you click the button. So you could do more complicated things here. You could update another plot. You could update another widget. You could update a plot. You can do what you want, basically. And I guess that's it for widgets event. And I think Matt will go next with layouts, unless we make a small break.
I think we've only been back for about 17 minutes, I think. So I think rather than taking a break, now we'll keep going if that works for everybody else. Okay, and I wanted to check, can you hear me okay? I'm having some trouble with my headset, so.
No, it's good.
Okay, great. All right, let me get ready to share screen here. Okay, so I am going to be talking through some of the notebooks in the layout folder. And we'll start here with notebook 0, then move through them in order. To give you a brief overview, we're going to talk about some low-level styling of individual widgets and then show you some high-level containers for putting widgets together. So what we're building towards is how would you put together a dashboard like those couple of examples we saw at the beginning. And before I get too far, how's the text size? Good. Okay, looks good. And if I'm going too fast, don't hesitate to slow me down. My first year of teaching, I read my evaluations, and one of the students said I was like a hyperactive gerbil on caffeine. So, and I haven't outgrown that. So if I go too fast, just speak up. We'll also talk a bit about, so back to the tutorial, we'll talk about some high-level container widgets for laying things out, and some styling that's available for a few widgets. In this folder, there are a few optional notebooks from past years that we've presented. We're not planning to go through those this year, but have kept them in there in case you'd like to read a little bit more. Okay, so now in the notebook 0601 widget layout. And so layout and styling of the widgets are two separate things. I want to talk about the style first because it's fairly brief, and then we'll spend a fair bit of time talking through the layout. So every widget has a style attribute. For most widgets, there's only one thing you can set in the style, and that's the width of the description. So when we've created a slider or a text box and included a description, the width of that description can be controlled, but the rest of the style of the widget can't be changed, although we'll look at several different layout options. There are a few widgets for which that's not the case. So for a button, for example, I can set the button color. Although I don't know why you would ever want to do this next thing. You can even make the button color yellow so that it's impossible to read the button. For any of the widgets, and this is useful to know for events and for style, you can find out what things you can link and observe by looking at the keys. So if you look at, if I were to look at b2.keys, that shows you the list of traits for the keys, or for the widget itself. For the style for the button, it looks like it can change two things: the button color and the weight of the font. The layout itself is a widget and can be shared between buttons. So if I make a new button here and I set its style to the style of B2, which is this yellow button, I'm using the same style now. And if I change the style of B2, so let's see, let's make the button color, come on, trying to get it to Oh, there we go. Red. That changes both of the buttons because under the hood they're using the same style object. Sliders have one style you can set. You can set the color of the handle. Here it's set to light blue. And for your reference, we've got a list here of all of the style keys. If you click that, it'll take you to a notebook that for each widget lists the style keys available for that widget. Oh, that's exciting. I see Jason's here, and we'll be able to do more styling in SciPy Widgets 8. There are a couple of other styles you can set. There's a button style and bar style where instead of setting the color directly, you're setting the style to one of the bootstrap styles, either success, info, warning, or danger, or primary. So if I set the button style for this new button to warning, it turns yellow. I think success green, danger is red, but this lets you do a little bit of theming at least. One thing to be aware of is that, set this back to warning, if you explicitly set the color, that overrides the button style. So here I'm setting the color to red and then changing the style to success, but the red wins over the success. I want to turn now to layout. And layout, there's a widget for layouts called the layout widget. And one thing that you need to be aware of as you are working with these is that all of these layout attributes are named for CSS properties in the browser. I mentioned that not because you need to use a ton of CSS when creating widgets, but I find that for example, it's not display I want. For the box model, there's a property I can set for the border. I can never remember which order the three things in a border are supposed to go in. So you have to specify the thickness, or can specify the thickness of the border, the color, and the style. And 9 times out of 10, I get the order wrong. And the thing to know is that when you start Googling for these things, you want to Google for the name of the property here in CSS, and that will take you to what you need to know. But there's a bunch of properties. We're not going to talk through all of these, affecting the size, the display model, positioning. Again, we're not going to talk through every single one of these. In a minute, I'll give you a link that does walk through all of these properties in quite a bit of detail. One other note for when you find yourself Googling for these CSS properties have a dash instead of a underscore. One choice that's been made in SciPy widgets is that we don't have the super granular CSS properties that are available in CSS. So for example, you can set a margin around a widget, and in CSS, you're allowed to do margin top or right or bottom and or left. Instead, we require that you set all of them at once by using the margin attribute. So here's an example where you're setting the top, right, bottom, and left. So let's look at an example of this. Okay, so this is a button. I've set the layout here. The width is set to 50%. There are a number of different units you can use for width, or for sizes rather. You can give a percentage. You can give a width in pixels. There's a width. You can do a width in weights. We'll get to later. And in this case, we've set the border to a 2-pixel dotted blue border. I can reuse the layout, just like earlier I reused the style. So if I make another button and copy the layout of the first, I get the same styling, and if I change the styling, so here I'm going to change the width to 30%, because I'm sharing the same layout with the two widgets, that changes both of their appearance. So quick exercise here. I'd like you to take like a minute and make the give the button a border which is solid and green, and make the width of the button 70 pixels. While you're doing that, I'll grab a Okay, so the color is, or the border piece is fairly easy. I guess I'll leave it 2 pixels and make it solid and green. I like to make these changes one at a time and run. Okay, so I've got the border right, and then so 70 pixels. Doesn't look very good, but I can make it as narrow as that if I want to. There are two basic layout methods or models that we're gonna talk through. One is a flexbox layout. We're going to come to that one second because many of the grid layouts are more straightforward to use, and in many cases you'll be able to design a dashboard or an application without having to get into the details of the Flexbox model. There's a very extensive notebook which walks step by step through the Flexbox model that we have a link to here. And so if you're curious to know more about that at the end of the tutorial, I'd encourage you to take a look. We've already used a couple of times an HBox and a VBox. Each of those is a container widget, one of them with a horizontal layout and one with a vertical layout. There's also a grid layout in CSS, and that uses the basis for a number of pre-constructed container layouts that are part of Itai widgets that make putting together applications easier than it once was. As with Flexbox, there's a very thorough but very long notebook about widgets in the grid model that I would encourage you to take a look at. And if you want to read about these in detail, we've also got a link here to a set of articles at online. So let's take a look at an example of the HBox and VBox. So in this example, we're going to make 4 buttons here, one for each of the 4 words here: correct, horse, battery, and staple. And we're going to put them together into a vertical box whose layout, whoops, sorry, wrong one, whose layout is given here. Right, so one thing to point out here, when the buttons were created, we set their width to auto so that the button will automatically expand to fill the available or the size of the container that it's in. So that if I were to change the width of the box, say to 70%, the buttons will grow with them. Or if I move it the other, whoops, meant to move it down to 10%. The buttons grow and shrink with the container. In the next example, we're going to, well, let me make it and then we'll talk through it. So this form has 4 rows in it. those 4 rows, each of those 4 rows is a horizontal box. One of the elements in the box is the label on the left. The other one is a widget on the right. To see how we've done the layout here, I'm going to make the form itself a little bit bigger so that it's 100% on my browser. So now let's back up to each of these individual rows. So the first line, the storage capacity line, for example, is created here. So there are two things going in this H box. One is the a label, storage capacity. The other is an int slider. Each of the items in here is laid out with this. Justify content controls how elements are spaced either along the row if it's a horizontal row or along the column if it's a vertical layout. What space between does is it puts the first object all the way to the left, the last object in there goes all the way to the right, and then the space is divided evenly around everything else. So as an example here, if I were to, in the third row where it says ship size, add another ship size. Name. And again, you can see that the space is evenly divided between the 2 ship sizes and the widget. If I had a third ship size, again, the space is evenly divided. Notice also we didn't have to do any special styling to get the drop down and the slider and the text boxes here to look good. They all have the same default size so that they'll appear nicely laid out. In a couple of minutes, we'll come back and talk a little bit more about text box. Or sorry, about the Flexbox layout. I want to talk a bit about grid now. And we're going to run through, we're not going to run through the details of the grid spec, but we're going to show you some containers that are useful. So this starts with some setup. And what we're doing with this setup is creating a series of buttons, 4 buttons. And in each case, the button has a description and a style, and we're applying a layout so that the height and the width of the button is auto. So the button will expand both vertically and horizontally to fill the container that it's in. There are a couple of text boxes and sliders, which we may not end up using, that use a similar layout. So the first layout I want to show you is called the 2x2 layout, because it takes the widgets you give it and puts it into a 2x2 grid. One of the nice things about this is you can change how much space each of those takes up to some extent by simply omitting some of the definitions. So in this case, we're going to provide a top left widget, a bottom left widget, and a bottom right widget. So we're not going to have a top right widget. And when we do that, the bottom right expands to fill the available space. You can prevent that if you want with the merge keyword to 2x2 layout. So this is the change I've made from the example I just ran. And with merge equals false, the bottom right doesn't fill in. Okay, so you can access each of the individual widgets in the grid in a way that's, I think, fairly intuitive. If I want to get to the bottom right widget, I just do whatever I've called the layout.bottom right, and if I change its button style to primary, the style changes. We'll see when we look at another Flexbox example in a little bit that you can get to the children of a Flexbox also. But in that case, you get there by accessing the children and giving an index number for the child that you want. And if you have a bunch of widgets that have nested widgets within them, that can be a little bit confusing. We had left out the top right button. We can add that in later. And you can control the styling of this a little bit by changing things like the grid gap. So this has now put 10 pixels between each of the elements. So far, we've just used simple buttons as the style, or as the widgets in each of the corners. We can do more than that. In this example, there's going to be a graph created in BQplot, and we're not going to don't expect that you're going to absorb all of this code at once. For our purposes, what matters is that we're making a figure. And in a moment, we'll make some sliders that control the maximum minimum values of the axis for that figure. So let's talk through this cell a little bit. We're making two sliders, one to control the maximum value of the graph, one to control the minimum value of the graph. We're making an app layout, or a 2x2 layout, where the top left slider is going to be the minimum slider, bottom left is the max, and we'll set bottom right to be the figure that will automatically expand to fill those two cells. And then we're doing some linking of the Y scale of the figure to the, and its max property, to the max slider value of the max slider, and same for the min. So let's take a look. As I drag the min slider, you can see the minimum on the graph is changing. And as I grab the max slider and move it, you see the maximum value on the graph is changing. I found it a little bit confusing at first that as I'm changing the max slider, the min slider is moving. The reason for that is that the maximum value of the min slider is linked to the value of the max slider. So I've got the max set to 5 right now. That means the highest that the min can go is 5. If I change the max to like 10 or 9.4, whatever, then the highest I can go with the min slider is 9.4. In a similar way, setting the min is setting the minimum value that the max can go to. But because the range of the sliders is changing, that's why the handles are moving around. So let me pause, see if we've got any questions. Looks like no. Okay, and well, let me ask you to do one thing here, because if we don't, I think it's going to mess us up later. I'd like you to change the name of this app to something other than app, so like BQ Fig or something. The reason is that we're going to reuse this variable app in a couple minutes, but I want you to be able to reuse this widget also in a couple minutes. So go ahead and give it a different variable name. So another layout is the app layout. Again, we're going to populate that first with some buttons that are created here. We're calling the function we wrote earlier so that these buttons will expand to fill the space available. So we've given the app layout 5 widgets, or 5 widgets, a button for the header, a button for left, center, and right, and a button for the footer. So this is meant to provide a template for a fairly standard app layout, or layout of an application where you've got a header, footer, and maybe a couple of sidebars. Like with the 2x2 layout, there's some automatic merging that happens. So here I've left out the footer. You can leave out the sidebar. If you leave out looks like I left out the right sidebar here, the center expands to fill the space. So take a moment here. This is should probably only take you 30 seconds or so. Copy and paste, and then make a application which has no sidebars.
We have no sound from you, Matt. I can see you speaking, but...
So you know it's 2021 because I stayed muted. You'd think after a year and a half of living this way, I would remember. Thanks, though. Right, I just left out the left sidebar, the right sidebar, the center expands to fill the space. You can control the relative width of the center buttons, or not the center buttons, but that middle row of buttons, by setting the pane widths. So when you set this, you're giving 3 values, one for the left, one for the center, one for the right. I mentioned before, there are a number of ways to set sizes in CSS. So in this example, we're setting the left button, or will in a moment set the left button to be 200 pixels. And then we're saying take the remaining space and give size the center button and the right button so that the center is 3 times the size of the right. There's an alternate way of saying that you want to use the remaining space, and that's to use 3FR and 1FR instead of 3 and 1, but they both mean the same thing. You can also adjust the pane heights. So here the 3 values are for the header, for the center row of widgets, and then for the footer. So in this case, the header will be 100 pixels tall. 5-1 means take the remaining space, divide it between those 2 rows, and make the middle row 5 times larger than the bottom row to get this. If you want to, you can change attributes of the widgets that make this up. You can also swap out widgets if you want to. Let's make one more. So you can, instead of specifying the pane width and the pane height after you've made it, you can specify it when you create the widget. So in this case, we're saying we want the left sidebar and the center to be the same size, and each of those to be 3 times the size of the right sidebar. And for the heights, we want a sort of a short header, a middle row that's 5 times the header, and then a 60 pixel footer. Okay, another short exercise. I want you to make an app layout where there's no header. Oh, sorry, where there is a header, but there's no footer and there's no right sidebar. And I want you to make the center that BQ plot with a slider that we ran above. So you'll want to start by copying and pasting in app layout, and then yeah, well, I'll let you go from there. I see that there was a question about a reset button. Was that question about the resetting the relative sizes, or was that about something else? And since you can't reply verbally to that, if you can say in the chat which one you're asking about, I'll try to address that question. That's an excellent question. Okay. So there's 2 questions that look like. One way is how to get back to the default pane widths and pane heights. I'm going to try something and see if it works. And if it does, great. If it doesn't, then I will ask the other folks on the call if they know. So I'm going to try setting the pane heights for this one back to none. Yeah, that's not allowed. Anybody else here know whether you can reset back to the original sizes?
Maybe there is a way to get the default value for an attribute in threadlets. I don't know. I can look it up.
Yeah, thanks. If you can take a look. I don't know off the top of my head. And then the other question was about the whether or not you could reset the axis sliders. So let me show my solution. This. Right, I didn't call it BQ app. I called it BQ Fig. So the main point of having you set this up as a using the app layout was just to try to emphasize the point that any one of these entries can be a fairly complex set of widgets. To answer the question about a reset button, yes, we could add a reset button if we wanted to. So I don't think I'm going to try to live code that. But the idea, let me scroll back up to the code where we created this. Off the top of my head, the way I would probably do it is add a button in here, and for that button's on-click action, I would have it. What would I have it to? Oh, where would I put the? Yeah, so what I'm struggling with a little bit right now is where I would put. Oh, I know what I would do. So here's what I would probably do. I'll just write this out in pseudocode. So I'd probably make a. Let me stop because I'm pause for a second and explain what I'm thinking about, because I'm pretty sure that I'm totally clear in my head right now, but haven't said about half of it out loud. So the way that we made this graph was the min slider was the top left, the max slider was the bottom left, and the graph was the bottom right, but it expanded to fill the whole space. So if I want to stick with the 2x2 layout and I want to add another button in here, I'm stuck because there aren't any more rows or columns to stick that button into. So one way I might approach that is to create a VBox with both of the sliders and a reset button, and then use that VBox as the, say, top left for the 2x2 layout, and don't use any, use none for the bottom left. So the VBox will expand to take up the full left side space. And then the on-click for the button would reset the slider values. Yeah, so in principle, yes, you can add as many features as you want in here. It does sometimes mean, like I had to do, stopping and reconsidering, okay, does the 2x2 layout really work for what I want to do now, or should I switch to a different layout? But I appreciate the question, because it let me make the point that, one way to address that is you stick with 2x2 and you just change what you're putting into the left side. Make it a VBox instead of making it a couple of the base widgets. Get back to where we were. We've done the exercise. I'm just going to hit a couple of the highlights of the grid spec here. So the grid spec layout is modeled on Matplotlib's grid spec. To make the grid itself, you say how many rows and columns you want, and then to put widgets into any of these entries, you treat the grid like an array. So to put a widget a particular entry, you just give its row number starting at 0 and column number starting at 0, and the widget gets put there. I have to stop and think really hard about these every time I see them. but the placement of the widgets and which cells they take up can be controlled by using a slice of the grid instead of using individual grid elements. So another way to make up that widget with the sliders and add a reset button might be to switch to a grid spec layout and put the reset button in one entry and the two sliders in a couple of the other entries. You can access the individual widgets by index, and then if you wish, change their properties. You can change the buttons. And so on. I think I'm going to skip this cell. You can run it yourself. What it does is creates a grid spec layout that's 3 by 3 with a bunch of charts in them. There's no meaningful data in those charts. It's just meant to demonstrate that you could use this grid layout to put together a dashboard in a fairly straightforward way. So one last grid box example. In the grid box, you give so this is, we've covered a few different grid things now. The grid spec, you treat the grid like an array and access it using indices. With the grid box, you give the box a bunch of children and you give it some guidance as to how you want to lay those children out. In this case, we're giving it 12 buttons. We're telling the box we want it to be 50% of the available space width-wise, and we're giving a template for the columns that we want the column widths to be 100 pixels, 50 pixels, and 100 pixels, and we're giving it a template for 3 rows of 80 pixels high for the first row, auto height for the second row, 80 pixels for the third row. So now the layout knows that we want 3 columns. So it's going to take however many widgets we get them and put them into 3 columns. And for the first 3 rows, we've been very specific about what size we want the, or how high we want the rows to be. As you could add as many children as you want and it will render them, but the explicit sizing was only provided for the first 3 rows. Okay. Let me check in with the other presenters. So I'm looking at the time, and I think I should wrap up fairly soon here. So I'm inclined to skip the exercises and encourage you to take a look at those on your own. I want to show you one more way of defining the grid. So you can define the grid area in words. So in this last example here, we're creating, again, using buttons to lay to as our sample widgets. We're making 4 widgets, one called header, one called main, one called sidebar, and one called footer. And for the grid template, we're providing this. So we're saying we want the header to span 4 columns, the main to span 2 columns in the middle row, and then the dot means a blank, and then the sidebar is on the right side, and then the footer spans all of the columns also. So that's what that looks like. So this provides a sort of visual way of laying things out. If I don't like that gap in there, I can change the dot to main, and there I go. If I wanted main and sidebar to occupy the equivalent of, oh no, that doesn't work. Okay. Thought that would give me as much. All right, any questions? Okay, other presenters, we've looking at our schedule, we're supposed to start the more widget libraries at 20 minutes after the hour. So I think I'm inclined to not go through the Flexbox notebook and move into the other widgets after maybe a 5-minute break. Does that sound good?
Sounds good.
Okay, so we'll take a 5-minute break and come back and take a look at some more widget libraries. I really love the emojis, by the way. This is great. we'll get started again in just Itai, take it away whenever you're ready.
Sure, yes. Thank you. Let me just quickly share my screen here. Is this large enough for everyone?
Maybe go one more up.
Okay. I mean, I'm just going to give the intro now. I think we immediately jump into. Oh no, we actually have SciPy Canvas before. Okay. Right. So this is the additional widgets library section, and we will talk about basically libraries that extend or sort of build on top of the Itai widget ecosystem. So what you've seen so far are just widgets that sort of come with the Itai widgets package, but really the Jupyter widgets ecosystem has a pretty rich protocol that can be extended if you wanted to write custom widgets on top of it. And this is what this section will cover. If you're interested in building your own widget, there are a few examples that you can find here under author your own widgets library, and with some great examples as to how you can get started. And you have some cookie cutters that will basically set up the boilerplate for you and give you like a very basic widgets to start modifying and then sort of grow into your own widget library. In the earlier days of this tutorial, and I guess Itai widgets as a package, the ecosystem was quite thin, but we have seen an explosive growth in the number of custom widget packages that have been authored in the last 3 to 4 years. So actually, if there is a widget that we're not presenting here that that has some functionality that you are missing or looking for, it is probably likely that someone has already created it. So let us know if there's anything that you would like to achieve, and we could potentially point you in the right direction if that exists. This list needs to be updated. We in last year's and previous years SciPy presentations, we presented some packages that were what I would call the staple packages. So stuff like bqplot, in Py3.js and IPy volume. For this year, we decided to showcase some newer packages that have come into the ecosystem since and have gained popularity. If you are looking for more thorough demos of some of these packages that we're not showing today, definitely review last year's recording on YouTube where we go through these packages in more detail. Okay. And Mariana, remind me, you're the one doing IPy Cytoscape and IPy Gani, right? Okay. Right, so let me just get rid of this right here. Okay, so iPy Canvas is a Jupyter widget that exposes the canvas context of the browser for you to make use of inside a Jupyter notebook. So Canvas is all web browsers, all modern web browsers have this element that is called a canvas element that allows. It is a very low level sort of canvas that allows you to draw pretty much anything you want. By quite literally specifying, the pixel, which is the origin point, and the pixel, which is the end point, and sort of draw a line between them or some sort of like a shape. And iPy Canvas gives you binding so that you can control and manipulate that API from this Jupyter notebook here. It was authored by Martin, who is on this call. So if there is anything that you would like to know about this package, definitely feel free to reach out to him in the chat or reach out to me, but he's probably going to know the answer. He's more likely to know the answer than me. But yes, let's get started. So just gonna import the usual suspects, NumPy, and then we are importing these different objects from the iPy Canvas package, and I will describe these as we sort of go along. So the first thing we have in this line here, I'm just going to execute this, is we create a canvas object, right? And that sort of creates this little canvas that you see here. Then you can specify what kind of fill you want, as in like what kind of color you want to fill it with. The stroke will be this outline here that you see. The line width will be how wide this the stroke is, and then we have and then we say fill polygon, and then you sort of give coordinates here, which gives you this basically this coordinate for one part of the triangle, another part, and the third part. I believe that's in pixels, and the same thing for the stroke. That sort of goes around it. By the way, I can't see the chat, so if there's anything that is not answered in the chat or that you want to sort of bubble up to me, just if one of the presenters, feel free to hold your mic, and I will try to answer it on the screen. Okay, so this is another example. Isn't that cute? We have a little heart. Again, similar idea. We create a canvas. We specify what kind of colors we want the fill to have. So the first thing we do is we have a fill style of white, and then we create this rectangle, right? That's the first thing that gets rendered on the screen. And then we set the fill style to purple, and then anything that we draw after that line will be a part of that purple. We'll have that purple filling. And here we have a path, and basically we start that path, and you can see that you have like this Bezier. It's some sort of function that allows you to have these like curved lines. So we sort of define this path that follows this like Bezier curve until we're happy with what we have defined, and then we fill the canvas with that color. So this is another example. Again, I think at this point, pretty self-explanatory. You just have a line with points, and that come from random data generation in NumPy, and then we plot that just with the stroke line function. Those of you who love your fractals and your Mandelbrot, there's an example here on how to draw a tree. I believe that should generate a random one each time. That's pretty cool. the code here is quite involved, so I'm not going to try and explain what's happening here, but if you do have questions, feel free to ask either in the Slack or hit me up later, and I'm happy to answer any questions about the logic here. So this one is quite cool. So I'm just gonna see quickly what it looks like, right? This might be nicer if I create a new view for it here, and then I drag it to the right. This is a great little option that Jupyter Lab gives you. Very similar to what Jupyter Sidecar does, just that Jupyter Sidecar will do this programmatically for you, so you can execute a specific code cell and it will generate that second output for you. But I'm a big fan of this because it allows me to sort of show you what the output of the set is, and at the same time, show you the code. Again, there's quite a bit of it's quite involved, but this example shows you basically just how elaborate and how creative you can get with Itai Canvas and creating these different visualizations. So this to me looks like a proper professional chart. If you wanted to create your own visualization library, theoretically speaking, you could do that with Itai Canvas. This is one of the cooler features. It's basically allows the output to have these like notes that seem as if they're handwritten, and that's all you have to do is just, instead of declare just a normal canvas object, you just declare this rough canvas object. And the API for both is exactly the same. So you would again have like a fill style and a stroke, and you would draw these rectangles and lines. And Itai Canvas will sort of take care of making it look handwritten for you. So this is, just zoom out quickly for the output. This is quite a big canvas. So you can see that there's some sort of animation here, the game of life. Right. And this is something that you can do with a loop, right? And basically you have a function, and that function basically redraws the canvas with each step. So you can also have some sort of animation. The nice thing about Canvas is that it is very fast to render on all browsers because it is a low-level API. So you can actually achieve pretty good frame rates if you do use Canvas. I mean, this is incredible. Well done to you, Martin, for coming up with these visualizations. Okay, so there's quite a bit of math involved here, which I don't understand, but it does what it's supposed to, right? And you can get these really creative shapes drawn on the canvas. I think that's it for the demo. And if there's anything that you would like to you would like us to clarify specifically to some of these examples, let us know in the chat. And that is it for Itai Canvas. And I think I will hand over to Mariana so she can talk about Itai Cytoscape.
So I'll share my screen. So SciPy Cytoscape comes from a desktop application called Cytoscape, and the point of this application is to generate graphs, networks. It's network visualization, and the point of SciPy Cytoscape is try to transfer Cytoscape, this graph visualization tool, to the Jupyter notebooks and to make it interactive. If you generated graphs with matplotlib or libraries like this, you will realize that they're just a static image and you can't control them. But SciPy Cytoscape allows you to interact with your graphs.
Mariana, could you make the text size a little bit bigger, please?
Yeah, of course.
That looks great. Thanks.
Yeah. All right. So let me just start my timer so I don't go too much over time. So in this walkthrough, we're gonna talk about the different types of data that SciPy Cytoscape can receive. So it can receive a default JSON type, which comes from the Cytoscape JS, which is the version of Cytoscape that we're porting here. We're gonna pay special attention to the pandas, to the type of pandas data, because we're in SciPy, and I think it made more sense to talk more about it. We're also going to talk about network X and Neo4j. So, and in the end, we're going to talk, and between this, while I explain how to interact with these different kinds of source of data, we're also going to talk about like how do we interact with it on SciPy Cytoscape. And in the end, I would like to talk a little bit about how a third-party widget like SciPy Cytoscape is interacting with the core SciPy widgets and how, you can use both of them. So you import SciPy Cytoscape and you create a widget, an object widget, and this is how you load a JSON, the default JSON format from Cytoscape. There are many different options that offer you different interactions with the graph, and you can learn more about them in the Cytoscape documentation. I'm not going to go through it. But yeah, you can also load the JSON. You don't have to paste the JSON on your Jupyter environment. You can also load it using Python functions. So here, to add a JSON graph to the Cytoscape object, you simply call this function, add graph from JSON, by selecting the graph object inside of the SciGraph widget and pass the data that you want to call. You're going to see that you add any of these kinds of data that I showed in the beginning that Cytoscape offers support to. You're just going to call the same function but with different names. So this is the default layout of a Cytoscape graph with these colors. And as I said, you can interact with it. And later on, we're going to see different ways to make this interactivity more useful for the user. So this is one layout. This is the default layout. If you don't pass anything to the graph, that's how it's gonna show. But SciPy Cytoscape supports a number of different layouts. And here's an image with a few different kinds. This is a grid layout, a circle layout. This is the breadth-first layout. It keeps the hierarchy between the nodes, if you have any. Here, just setting a different layout. This is how you set a layout. Use this function, pass the name of the layout. And this is the random layout. What it does is generate a layout with different positions for the nodes and the edges. So every time I run the cell, I get a different configuration for the graph. So for pandas, first you have to import pandas. And then we're creating a new widget here so it doesn't mess up with the other widget we just created. And here I'm creating a very simple data set just so we can work and understand like our data as a whole. So here we have a column with robots, and we have Marvin, C3PO, R2D2, and data. And then we have the universes of these robots, Douglas Adams, Star Wars, and Star Trek. And then their coolness level, 10, 3, 10, and 10. And then I'm going to just create a data frame, a pandas data frame with this. And here, the way you add pandas data frame to IPyCytoscape is a bit different. You have to first pass the data frame that you're going to use. And then the second argument is the relationship between the columns you want to use. So in this example, which is a simple one, I want to make a relationship, create a relationship between robots and coolness level and their universe. So I'm going to show you how does that look. And so we have this. We have 3 little blobs on the screen, and it's easy to see that this one is Star Wars because it has 2 data points. But the other ones, we don't really know what they are about, right? So let's try to add some more information to these. If you print what's inside the graph object, inside the nodes, you're going to see that IPyCytoscape generated automatically for you a bunch of nodes with a bunch of automatic IDs. So here, for example, we have the universes as the parents. So we know that the lighter blue is a universe containing the children, who are the robots. So Marvin, C3PO, R2D2, etc. So one thing that we can do to make the data comprehension better is try to create edges between these nodes. So for example, you can create an edge object, which is, you have to create a cytoscape object, which is an edge. And then you can add the method addEdge and add this edge to the graph. So now we, in here, we were creating an edge that's connected the node that had an ID 1 to an ID 2. And those happen to be C3PO, PO, and R2D2. So here, there is an edge between these 2. Okay, but that still doesn't say much about the data. Another example here is that you can also create edges between the universe, the bigger groups. So here I'm connecting this universe to this one. And you can also visualize the edges of your graph by printing them like this. So to try to make this more understandable to humans, we're going to try to style it with colors. It's not pretty, but it's I hope it's easy to understand. So IPyCytoscape offers you the possibility to style with layout that we already saw. There are many different kinds of layouts, with style and with tooltips. The style configurations, they are very similar to CSS styling configurations. I'm not sure if it's the same because I don't know much CSS. But here, what we're doing is selecting all of the nodes and painting them blue. And we're selecting the ID that has the parent 1 and painting them yellow, and the ID that has parent 2 and painting them red, which is going to give us this result. So if we go back a bit and we take a look here where we printed the nodes, we know that the Star Trek universe is now yellow and that the Star Wars universe is now red. So that's a bit better. So yeah, if you want to know more about selectors and how they work, I linked it to the Cytoscape.js documentation because that's exactly the same as the IPyCytoscape. But now, one thing that would be useful is to set tooltips. So once we click a node, we actually know what's inside of it. So here we're setting the tooltip to show what's inside the name attribute. So here, if I click a node, I get the robot and their coolness level. So here's Data, the Star Trek universe, and here's Marvin from Douglas Adams, and yeah. So this is for styling, and there are more examples on how to configure these things and make them pretty here, linked on the notebook. So another data type that IPyCytoscape offers support to is Network X. So you're going to go a bit faster through this. You can create a graph with Network X. And then, as I said, simply add it using this method that's the same for all of the supported types, just change the name here. And then you have a Network X graph inside Cytoscape that it's interactive. Because you can also do it with Matplotlib, but then it's just a static image. IPyCytoscape also offers support to direct and undirected graphs. So if you have a directed graph, it shows it like this, and you can also mix the graphs and show both directed and undirected at the same graph. You can also create custom elements. So as you saw here, these are not very great names for dealing with data. So you could also create specific custom nodes with better IDs and better configurations for your data, and also add them inside IPyCytoscape. I'm not going to go into details with this because we're a bit short in time. But yeah, you could also make something that adjusts better to your data. And IPyCytoscape also offers support to Neo4j. Inside the Python universe, I think PyTuneNeo is the library to go to make Neo4j work with your things. And then to add a graph, you just do the same. I just didn't set up an example here because it's really complicated to set up Neo4j for Binder, and the local notebook is a bit complicated too. So talking about interactivity and interoperability with IPyWidgets. First, IPyCytoscape can listen to DOM events. So you can mix these two things, listening to DOM events and widgets interaction, and create really powerful applications. So here's a simple example. I'm getting the graph that we did on the beginning, and using the CSS styling, I added the following class. All the edges now have the highlighted class, and that means that all the edges that have the highlighted class will have their line colored red. So when I set the style, nothing happens because we didn't build the widget that's going to make this happen yet. So what we're doing here is creating a button and setting a callback on this button that every time that when it's clicked, I'm gonna go through all of my edges of my side graph and add the class highlighted to them. Because as of now, my edges have no classes, even though they have a style that say that when they have the highlighted class, they're gonna be red. So we can create this button, and then we click the button, then it actually goes through all of the edges and add the highlighted class. We can also listen for JavaScript events. So here I'm listening to the on event on click. So when I click a node for my graph, it's going to be painted blue. In Cytoscape, we have a problem with triplets, and we didn't fix this yet. But every time you set a style, if you wanna keep your past configurations, you have to set the style again. So we have to copy everything that we've done and add the new configuration. So that allows us to listen for events and change the graph as we click the buttons. Yeah, so these are all of the events that are supported by App and we have a little exercise, but I don't think we have enough time to go through it. So I advise you to go on your own, and I'll be available on Slack if you're interested in in getting the result, or if you have any questions. So I think that's it, and we go back to Itai.
Thank you, Mariana. Okay, so next up is SciPy Data Grid. SciPy Data Grid is a relatively new package that has been released by Bloomberg, co-authored with Quantstack, mostly Martin again, who has done some of the early work on it. The idea behind SciPy Data Grid is to provide something that has an interface that allows for that gives an easy way of working with tabular data in an interactive fashion that is still performant. So most of the people who use SciPy Data Grid are coming from Excel backgrounds, and they always like to have this kind of Excel-like interface available to them in Jupyter notebooks. SciPy Data Grid is also based on canvas rendering, so you can sort of spot the theme here. SciPy Canvas is built using Canvas or allowing users to render stuff using the canvas rendering context of the browser. SciPy Data Grid does the same thing. It renders the grid on a canvas, and that means that you get very performant rendering performances. So it's a very fast it's a very fast solution, even for very large data sets, which are becoming more and more common. There are some features that we will discuss, like built-in sorting and any filtering. You can sort of do that either programmatically from Python or from the graphical user interface. It comes as you'd expect with full integration with Jupyter widgets ecosystem, so you can observe different traits. You can have event listeners for clicks, etc., etc. And customizable renderers, we'll get to that. Two-way data binding is something that we found was really important for users of SciPy Data Grid. So being able to change something by clicking on the screen and changing it there, and then being able to retrieve that data back in your Python kernel by just basically reading the data from the grid. Vega expressions. Vega expressions are effectively a strict subset of JavaScript. So you can do all sorts of conditional formatting, filtering, etc. The idea behind Vega expressions, allowing only Vega expressions and not the full JavaScript, is basically to make sure that the code is sanitized and nothing malicious can run. Okay, so you can see that we have imported a few objects here. The data grid will be the main object where the data grid is rendered. Text render is a specific type of renderer that allows you to specify for each cell that is rendered in the grid what background color it will have, what font style, etc. Bar renderer is another type that instead of showing you text, it shows you bar. So it adds like a bar. Typically, that's great for something that has a range. Expression and Vega expression are two ways of doing the same thing, specifying Vega expressions. Well, we'll get to that in a sec. You can use any kind of data set that you want with SciPy Data Grid, but it is currently geared towards using. You would want to use it with pandas. That's where we found the best synergy. Just throw in your pandas data frame and it will render a grid. It's the most natural one. We're creating some dummy data here that I will use throughout, just put it in one cell so that you don't have to worry about where we get the data and sort of start going back and forth in the scrolling up and down in the notebook. So everything, all the data created is here. And we will reference these like nested df, small df, rand df when we're creating that data grid. The first one is going to be the cars data set that we loaded from a JSON file. And as you can see, I just create at the very basic level, I just create a data grid object with data frame passed in. Ignore this index. This is something that I should fix, but it doesn't affect the usage. And you can see that this just works, right? This thing rendered, and you can see the grid. We haven't enabled any like selectors or any clicking yet, but you're able to render the whatever your data grid, whatever your data frame had in a data grid with minimum effort. You can also create the grid with some additional options. So if you wanted to change the width of the row or the width of the columns, you can do that, and that gives you a bit more customization. These are also things, these are traits that you can change after the data grid has been created. So yeah, you don't have to do it now, but we are just showing you different ways. Sometimes you may not want to have any headers, any header renderer, so you may not want to have like the index column here, and you may not want to show the actual column names. These are all things, because I zoomed in, it's a bit harder to see, so let me create a new view for this. These are things that you can sort of, you can see, trigger. So you can do a lot of customization for styling the data grid. We found that that was really important for users. You may want to have some sort of conditional value to say, hey, if the value is above or below a given threshold, I want the color to be that or this. So some examples here. And this is just a function that we look at we're gonna call this on the horsepower column. Effectively, we're saying if the value, if the given car has a horsepower of less than 100, then color it red. Otherwise, if it's less than 150, color it orange, and anything above 150 or equal to 150 will be green. And a similar idea for the weight coloring. We then have this dictionary here where for each of the column names that we have in the data set, we specify a different type of renderer. So this is a bar renderer. And again, a bar renderer, you can see, will work with a scale that basically takes the minimum and the maximum value, and then it will sort of change also the color of the bar with the Viridis color scheme, again, depending on a value that falls between that range. If it's anywhere in between, it will color it according to whatever the Viridis color scheme is. If it's at the top, then it's going to be one color. It's at the bottom, it's going to be another. And a similar idea also for other ones, like miles per gallon. The miles per gallon is not using the Vega expression. This is what a Vega expression looks like in Pythonic, in a Pythonic syntax. But if you wanted to write the Vega expression directly, you can do that. Sorry, where do I actually have a Vega expression here that is written directly? No, we will get to that. Okay. Yeah, there will be an example of Vega expression down the line. Okay. I wonder which grid is. That might have been for the gridable. Yeah, that's that one. Should have kept the output of this. Okay. There we go. So we have just applied all these different styling here. There we go. You can scroll up and down. These scrolls are also rendered in Canvas. So you can see you can change a lot of things like the font size, color, etc., depending on the value. So this is what conditional formatting works like. You can also change that after. For example, if I want to change the name, and so where's the name? I'm sorry, where's the car name? Yeah, it's here. So this column here, I can change those, how these renderers render based on the condition after if I want. Same thing here. You can also style the column headers. So not just the body of the cell of the grid, but also the row headers and the column headers. Row headers are basically the index row. Column headers are just the column headings. So you can also style them. And now we're looking at a relatively colorful grid. You can also apply transforms and sorting. You can do this from Python or directly via the graphical user interface. So let me show you what doing it via the graphical user interface would look like. So you can sort of click here, and then, you can apply any sorting if you wanted that. So these are you can sort by horsepower. You can filter by value. So maybe you want something that has the exact value of, let's say, only 170. So I can toggle all of them and then just apply 170, and then you're going to see that. And you can also do based on condition, less than, greater than, etc. Everything that you've seen can actually also be done programmatically, right? So maybe you want to have some type of filter. You want to filter for the column index. Column index are starting from 0, not including the index 1. So this would be horsepower will be column 0, origin will be column 1. So we want 0, 1. Does that work? Maybe I got that wrong. I got that wrong. I think column 2 will actually be the third column here. So it does include the index. You can see basically that we have filtered to show only the European car manufacturers. And again, programmatically, we didn't have to do it from the grid via the graphic user interface. You can also format a cell based on the value of another. So this example sort of shows that. I think that's in a different grid now, conditional grid. Again, so the idea here, this is, by the way, where we're using a Vega expression. This is technically speaking JavaScript code, but you don't have to use that. Anything that you write with a Vega expression directly can also be used. You can also write using this normal expression function here. Okay, so basically, I think if the value here is positive, then we color the background of signal to buy. If it's negative, then we color the background to be red for a given stock. SciPy Data Grid also supports multi-indexing. So here is a nested column header, multi-index pandas data frame. So we have value factors, momentum factors that are 2 top-level categories. And for each one of them, you have different factors, factor A, factor B for value, and factor C and factor D for momentum. SciPy Data Grid can render those 2, no problem, right? So you can sort of see that. Again, I really like the conditional formatting. So excuse me for overdoing it. I just really like the color. But yes, this also works with a hierarchical data grids and data frames. And sorting and filtering will work here in exactly the same way. There are more enhancements coming to SciPy Data Grid very soon in the next couple of months to sort of make this model even more extensible, so you can merge actual grids, actual cells within the grid area, and have grouping for any indices, any nested level indices. So like we have factors here and momentum, and then you can have as many nested levels that you want on the column side. We're also adding this to be available on the index side. Two-way selections. So let's look at this grid here, and you can see that I have enabled the selection mode to be cell. So I can now actually click, and we now have a grid that is allowing me to select a value. And let me actually also put this in a new view, the output. So you can also drag the selections. So let's start with a single one and sort of grid selections, and you can see it gives you the range. So it starts at row 6, ends in row 6, and begins in column 1 and ends in row 1. You can also get the values for that. You can also, as I mentioned, select the range, and then you see the range here, and then all the values that pertain to that cell range. You can have multiple selections. So I can have one, and I can have this thing here, and maybe, let's say, another one here, and you can sort of see all of them coming up. Right, this one is only showing. This one seems to only be showing the last one. That should not be the case. I will look into that. Is it? No, it's actually showing all of them. My bad. You can also select. I selected using the graphical user interface, but you can also select if you wanted directly from Python. So I've selected these top ones. You can clear the selection if you wanted. If you need, if you're trying to select with a large, you're trying to, you've selected, let's say, an entire row or an entire column, you can actually, sorry, I got an alert that my connection was bad. You have an iterator, and this iterator here will give you basically an easy way of iterating over your entire selection without committing it to memory. Again, sort of something that only generates the value in a lazy fashion, only as you requested.
Itai, your screen share is gone now. Just
oh, sorry about that. Technical difficulties are part and parcel of live demos. So this is what the iterator would look like. Again, just something a bit more performant, and you can also select using this little format with the start row, end row, start column, end column. Selection modes, you can select on a row basis. So if I click anywhere in the grid, you select the row. The same thing also applies if you wanted this to be on a column basis. You can select anywhere in the grid, you will select the whole column. Here is a way where I can select only even number columns. Two-way editing. So if I wanted to edit the grid, that's also something I can do. Where was I? Sorry, two-way cell editing. So I can edit this row here. I think I might need to actually. This is not editable yet, is it? No, it is. Sorry. So I can sort of change this and see that based on my conditional value, if it's 1, then it's lime green, otherwise it's hot pink. So this can also be retrieved on the back end, and so anything that I edited can be retrieved directly to Python. You can sort of see me doing that directly if I wanted to write the Python. And just to wrap up, here is what did I want to show here? Yeah, any change events, right? So if I sort of change that 1, I can sort of print anything that changed. So this is just an event listener. Again, showing you how to integrate with SciPy widgets. And I have a last example here, sort of penultimate again, where we're using the widget ecosystem to sort of, here's a slider that controls the range of the color scale, and that I have rendering these bars. Again, just something cool to show you. Yep. And the last example here is something a bit more practical, I guess. These are random stock prices, and if you click on any of these columns, it will render them in BQplot. So something a bit more practical if you're trying to use SciPy Data Grid in conjunction with some sort of plotting library. And that is it for me. If you have any questions about SciPy Data Grid, feel free to reach out to me in the Slack channel. Thank you. I think we're on to Mariana now, right? Who will show SciPy.
We can't hear you.
And now we can't see you. Oh.
But can you hear me?
Yeah, we can hear you now.
Nice. Can you see me too?
Yeah.
Okay. Let me share it again. Can you see my screen?
Yes.
Cool. So iPython is another widget developed by Martin. And iPython is a library that enables visualization and manipulation of 3D data. And it's an attempt to bring functionalities of tools like ParaView to the Jupyter ecosystem. So in this notebook, we're going to talk about the warp and threshold manipulations, and also how to change the color of your objects. So what you should do here in this first cell, we're downloading an example from PyVista, and then because of that, we need to, oops, this cell is duplicated. For that, we need to convert it to iPython. So this data that we're downloading, it's a topographic data of the Earth. So it's the Earth high and down points of the terrain of the Earth, more or less. And so here we're downloading it. We're creating a PyVista mesh. And here we are converting the PyVista mesh to a iPython mesh so we can work with it. Here we're configuring a color for our object. So to configure a color, you have to pass an object, and also the mean and the maximum values that are going to be the extremes of your color bar. And in the next line, we are attributing this, and then this results into a new colored mesh. And in the next line, we're attributing this new colored mesh to our warp by scalar, which is the transformation that we're using So warp is a type of geometric manipulation that's used to transform the geometry of the data set without affecting its topology. So here, to use the warp biscalar, we first need to pass a mesh to it. And as an input, we need to give the attribute that's gonna, the name of the attribute that's gonna be the attribute that you're gonna change, you're gonna warp. And this is the warp factor, how much how strongly we're gonna warp our mesh. So here, we're linking the warp to a float slider, so we can change it with Itai widgets, and adding an observer function to it, and wrapping everything into a vertical box. So this is our data without changing it. And if you move the slide, you can see how the warp function interacts with it. And there are two different kinds of warp functions implemented on IPython, the warp and the warp biscalar. And the cool thing is that the warp makes its computation on the GPU, so it's much faster than the usual implementation of this function. So about colors, you can create color bars out of the ISO color mesh that you apply to your object. And there are many different colors, not only these that I added, but you can choose the one that matches your data the best. And the other thing we're talking about on this notebook is the threshold manipulation. So the threshold is a way of partitioning your data depending on the inputs that you give. So to work with not partitioning, slicing your data. So here we're getting a local event, a local example, and in this next line we're creating a color to it. So the input for the color are it can be a tuple of values, of the values you want it to be related to the color, and also again passing a minimum and a max value. And we're also creating a scene. So in this first cell, we're just loading the example, adding some color to the object that we created, and then showing this object on the screen. But it's taking a while. Okay. So you can move the object around. This is the object we loaded. And here we're going to create a threshold. So the threshold is gonna subset the data in relation to these two columns, which are part of the data we just downloaded. And so first we have to create a threshold, an object that is able to do threshold, and then we can make the cut depending on the maximum or the minimum value of the threshold. And we can do it like this. So if you move your object around, you can see that it was cut on the maximum value of the threshold. And we have a little exercise, but I also don't think we can do it because we went a little overboard with the time. Or should we do it, Matt?
I think we should probably keep going. And
okay.
I think what we'll do is jump to voila, and then if we have time, we'll come back to the other widgets library.
Yeah. Anyways, I'm available on Slack if you're interested in giving a try on this exercise. You just have to create a slider for it, and bind it to the value of th, so you can change and see how much you can cut your object. Yeah. So
okay, so while we're switching here, feel free to take an in-place stretch break if you want. While we're moving on to the next screen share, but I think we're not going to take a longer break than that. And somebody asked in the chat about how long the videos are available. As far as I know, they're available forever, both to participants and non-participants.
Okay, so we'll switch to dashboarding using Jupyter. So here I've got Jupyter Notebook. So one thing you might want to do with widgets is to maybe make a report or a nice visualization with it, and then share with someone who doesn't maybe doesn't know how to code and don't want to see the Python code. So one thing you can do is from the Jupyter Notebook, when you create a widget here, you have a small widgets tab on top, and you have embed widgets. If you click on this, it will show you some HTML code that you don't need to understand, but you can just copy paste this. And if I create, for example, an HTML file with this content, and then if I try to open it with my browser, I will see my widgets here, embedded in an HTML file. So this is completely static. So this means that your widgets, you just have the JavaScript part. You don't have the Python part of it. So here in this example, I was making a slider with a text input, and both were kind of linked. So in the notebook, when I move the slider, it will update the text input. But when you embed it in an HTML page, like I did, you don't have the Python execution running. So this is because I don't have a fancy Jupyter server running the Python code. I only have the JavaScript part, and it cannot communicate with Python. So one way to fix it is to use Voila. So Voila is a command line tool that you can use just like you would do Jupyter Notebook with the name of your notebook. You can do, let me just zoom in a bit.
Yes, I say, Martin, we can't read it.
Yeah. Is it better?
Yeah.
Oh. So if you do Voila and the name of your notebook, this will start a Jupyter server, start the kernel, execute your notebook, and then show you the output. It will only show you the outputs of the cells, so you don't see the code. And because there is a Jupyter server running the Python code, you have all the interactions that are still working. Then, okay, as you can see, it's pretty raw. I mean, it's just the outputs on a white page. It's not really pretty. So if you want, you can make it prettier, maybe using a dark theme. Just doing dash theme equal dark. So this looks a bit better. But then you can make it even prettier if you use templates. So Voila has a pretty complicated templating system. If you know a bit of HTML and CSS, you can make your own templates, but we actually provide some templates. So for example, you have the Voila material template that maybe I can share the link in the discussion. So if you use the Voila material template that I installed, doing dash template equals material, this will use my template, and I will have a nicer dashboard. So this one is having a big Voila header, but I don't know if you want to make if you want to show the logo of your company or of your project, you can do it. You can make your own custom template and play with the CSS and make it really pretty. So let me just switch back to lab. So one thing that is nice is that when you install Voila, you should get a small button there. So this button says render with Voila. If you click on it, you actually get a preview of your Voila dashboard inside the Jupyter Lab UI. And you have a small button there that says render and save. If you check this, and if I make changes in my notebook, and then save, it will rerun Voila and show you the new output for your dashboard. So this is nice for developing your dashboard and making changes, making CSS changes and everything. So one library which we actually didn't show this year is SciPy Beautify. So this library, it's basically SciPy widgets, but using a material design look and feel. So yeah, this is PQ plot that we also showed quickly. You can make plots, and in SciPy Beautify you can make sliders, just like with SciPy widgets, but it has a material design look and feel. And yeah, SciPy Beautify is really nice. It has multiple things. You can make tabs. You can make complicated layouts, just like with SciPy widgets. And if you install, I will go down. If you install the Beautify template for Voila, I can share links as well for that. If you use this template, Beautify default, it can make your notebook looks like this. And this is my notebook. I've got widgets still reacting because I've got my Python server running. And this is BQplot. I make selections and I get a histogram. And this is a notebook that is powering this using Voila. So this is pretty impressive. So yeah, that's it for Voila. I will share multiple links, but you can already find them. You should find them in the notebook. And I guess we have a bit more time. I can maybe show the notebooks that we skipped. So there are other libraries that we wanted to show, but we can make it this quick. We can make this quick. So Hyperleaflet, it's another library.
Can you?
Yeah, sorry. Seems it's coming back to the initial setup. Anyway, so Hyperleaflet is another library building on top of HyperWidgets, and this is exposing the Leaflet.js library, which allows you to make interactive maps using interactive widgets. So here I loaded a GeoJSON file, and then I created this widget here, and whenever I hover on a GeoJSON feature, it will update the widget on the top right. Then you have Py3.js, which is exposing the 3.js library for doing 3D in the notebook. This is really crazy. It's really nice. Then you have BQplot, the plotting library. This one allows you to update the data dynamically from Python with nice animations. You can do selections, you can do anything you dream of. And then IPyMPL. And I don't have IPyMPL installed. But yeah, you have IPyMPL. Actually, you saw it before at the beginning of the presentation. And because we have a bit more time, I would like to speak about Jupyter Lite. So Jupyter Lite is another, it's something that we started working on at Quantstack, and it's basically another Jupyter Lab distribution, but it's entirely running in your browser. So this means you don't need a custom complicated server to run it. Just a static web server works. So for example, this means that you can actually deploy Jupyter Lite on Read the Docs or on github.io, if you know that. It's pretty cool. And you have an example there. I will share the link in the discussion as well. So if you click on this link in the README, try it with Jupyter Lab. This will show you, it will start Jupyter Lite in your browser. You will see that it's a lot faster than Binder, it's crazy. And yeah, I will actually start it, sorry, using a private window just to clean the cache. No, it's there. And Jupyter Lite provides a Python kernel, which is named PyOLite. And this is actually powered by Pyodide, which is Pyodide. It's basically the Python interpreter compiled in WebAssembly so that it can run in your browser. And
Marta,
really...
can you zoom again?
It's really I can zoom again. Yeah. Sorry. So yeah, the PyOLite kernel. If you start a new kernel, you will see that you can actually execute Python code. It takes a bit of time to start because it installed stuff from SciPy. But once it's started, it's actually super fast. It's I wouldn't say it's as fast as running in the server, but still it's pretty decent. And yeah, so the PyOLite kernel, it's pretty new, but now it's also powered by IPython. So you have all the features of IPython. You have magics, you have you have interactive display, and everything. And it doesn't start. Sorry, this is the demo effect. Let's see if I can start another one to show you that actually widgets work in PyOLite. And as you can see here, what I do is I install IPyCanvas using micropip, which is a smaller pip for Pyodide.
Marta, again, check that check that Pyodide is downloading.
Yeah. Okay, so this is actually the demo effect. I think master of Jupyter Lite is broken. So let me just see if I made a backup for that, fortunately. So if you try this link instead, let me just find it. Sorry for the mess, it's pretty new, all of this. So if you try this link, it will actually work. And I will try it myself. They don't have the same notebooks, but this is not a big deal. Yeah. Too much. Here you have interactive widgets working, hopefully. Yeah, it is starting. Yay! And here it goes. Widgets running in my browser. So yeah, it's still pretty new. You might not have exactly the same behaviors as when you use the classic Jupyter Lab with the classic kernel. Some widgets might not still work. Pyodide provides NumPy and Pandas by default, so you don't have to install them. They are actually available, and they are compiled to WebAssembly as well. But not all libraries work, unfortunately, because every time you install something in the web page using micropip, it needs to be a pure Python package. Otherwise, you cannot install it. The only way to install it would be to compile the package for Pyodide, which is, of course, less easy to do. So I guess that's it. If you have more questions, I guess we have time. Would be nice to persist it on a cloud storage. Yeah, so actually your browser should be smart enough to cache a lot of the data, and it will actually cache the page, the notebook, and I guess some of the packages that you install. I'm not sure about that, but it might happen.
I think micropip ones will not be cached.
Okay.
But everything else that is downloaded directly with like a XHR or fetch that is a JavaScript file will be cached. But nevertheless, this demo may it makes this thing looks very easy. Just Jupyter Lab running in the browser, and you have a Python kernel. But the sophistication of the engineering effort behind this is incredible. To get this thing working, you have to have so many moving parts. And to get widgets working on top of that, it really is incredible. So this is a really exciting project to continue watching.
So we've got about 10 minutes left. If there are any additional questions.
I think we have a question in the Q&A.
Was that the one about using it with Flask and that kind of thing?
Yeah, I didn't get the question from him.
I guess Gerard is asking whether widgets can run using a Flask server. I think it needs to run widgets. The widgets work on assuming that there is a Jupyter notebook server running, right? So that you have, because that is the glue that provides the binding between the Python side and the JavaScript side. You don't quite have that with Flask. You could potentially serve the static HTML that Martin showed that you export when you embed static widgets in a HTML file. You could potentially serve that, but that probably is not what you're looking for. So I don't think, or you could serve Jupyter Lite. And then if you serve Jupyter Lite from Flask, you sort of circumvented that problem. But again, probably not what you're looking for. I don't think there's a way, and correct me if I'm wrong, I think we also have Jason on the call. I don't think there's a way of running Jupyter widgets just with pure Flask.
So it looks like there's a follow-up question. So there does need to be a server running to use the widgets, but that server can be running on your computer. So if you, at the command line, type Jupyter Lab, then in the background, it's starting up the server for you, and you execute from there. So you don't need to have a third-party server or something like that to make this work. And in the chat, there's a Jason Grout put an example of using Flask with Itai widgets.
I actually had no idea about this. This is really cool.
Any more questions? Oh, yeah, I just saw one come up there. Last call for questions. Ooh, can you put a link to IPy Data Grid into the documentation into the chat?
Sure, with pleasure.
It looks like there aren't any more questions, so I guess we can get an early start on lunch. If I remember the schedule right, lunch is from 1 to 2 Central Time, and then the next round of tutorials starts at 2 p.m. So thank you all for coming and for sticking with us. I know it's I know I'm reaching my limit of the number of video conferences I want to do, so we really appreciate you devoting 4 hours today to learning more about widgets, and look forward to hopefully working with you in the future. Well, I think we're all around this week, so feel free to reach out to us on Slack if you have more questions.
Thank you, everyone.